Hello everyone, welcome. This is the second part of preparing the Raspberry Pi for Magic Mirror and home automation. If you haven't watched the first video, I suggest you go back and watch that one first and then come back to this one. Thank you and hope you enjoy. Before we start coding, let's just see how I connected the motion sensor. It's very simple. This one requires 5 volts, so I just hooked it up to 5 volt and then used one of the IOs on the Raspberry. And you will see in the code later on how I'm using it to control the display, turning it on off again. To get started with some code, we have different options. First of all, we have Python editor installed, Thony, that you can use. It's locally on your Raspberry, and I have used it a lot, but it's not so smooth to edit files and debug files directly on the Raspberry Pi, especially since you have to use VNC to access it. So I would actually recommend that you spend some time on installing Visual Studio Code instead. So I will show you how to set that up. But first we need to make sure that we can log in to Secure Shell. So you want to bring up your configuration file, and if you don't have set up any other authentication methods, you need to find the entry password authentication yes and remove the bracket from in front of it, the comment, and then you can save next the file. I have already installed Visual Studio Code, but there are a lot of documents on the internet to get you started with that. But first of all, you need to install it, and that's quite straightforward. And then you need to make sure that you have an extension called Remote SSH. So this extension you need to install. And if you don't have it already, you can just install it from extensions here. And when that's done, we can open up the Remote Explorer. And here we want to add our new Raspberry Pi. So let's add a new remote. First the username and then the IP. Like this. And save it in the config file. And it should show up here. And now we can try and connect. Since I already connected, I don't get any keys downloaded, but if it's the first time you connect to that IP, you would have to approve the public key that you get. In this case, I go directly to password, and let's see if we can log in. Yes, it's logging in, and it's actually also verifying and installing the Visual Studio Code parts on your Raspberry Pi. And that's it. And now we're up and running. And I can go to Files, Open File, and I can see it's actually browsing my Raspberry. And I have created a folder called Web Server. And in this folder, I have put my example or template for the web server that I want to start on the Raspberry to use for the Magic Mirror. So let's open that. Before we start going through the code, I want to highlight one more thing for you, and that is that you need to make sure that you also have the extension Python. This helps you in writing the Python code and interpreting the Python code. So you should also install this extension into your Visual Studio Code. And you can find it here in the extension market and search for it and install it. There's no special configuration. So let's start with the code then. We will start from the top, and as I said, this is just a shell. This is the start of the Magic Mirror. So there will be just a few lines, but just to get it up and running, see that everything is working. First of all, I have included a couple of libraries here that will be useful. Not so much to comment on them. I have the threading library to start threads to do multi-threading, which is needed for running simultaneous things in Python. The important stuff here is the Flask web server that's installed. That's the web server that will actually be used for presenting the Magic Mirror screens. I have a JSON library as well to help me construct and interpret JSON, and some date and time libraries and so on. So quite a good start. And then we set up a few variables or static variables, the IP address and the port that I will be using for the Flask web server, in this case 8081. I also just making sure that I start everything in the web server directory that I created before. It's just make things easier. Then we have a couple of settings for the motion sensor. You will see more details about them further on, but in general it's enabling the JPIO, and I have put my motion detector sensor on IO23 here. 0.5 here is actually the polling time, the interval that I will be checking the motion sensor for. Initiating the Flask object here. And also setting up two different threading locks and threads. The first one here I will use for the motion sensor and polling it every 0.5 seconds. So that's the first setup. You can read a lot about the Flask web server on the internet, but you will also see some of the basics here when I go through them. First of all, I start a very, very simple web server, and this means that I start it at the top, the root. So I expect somebody to call the root of the server. And when that happens, I will just do a very, very simple construct here. I will get the date and time of now, and I will create a time string with hours and minutes. The next part here is the JSON, and I will be using that quite a lot, both for my communication to my devices, to my Arduinos, but also in general when communicating with REST APIs. JSON is a good thing to start with. So I'm creating a JSON array here with the time string that I have just prepared. And then at the end here, I will return the data from the JSON I constructed, and I will return it to this page. And this is the HTML page, the main page of the Magic Mirror web server. A few more things here. I define the interrupts here, and you will see more about that later on. But I think that we should actually go down to main for now. And here you can see in the main that this one we don't need actually, call the peer function. And the peer function we have up here. And this one is simply reading the IO pin and checking the status of the IO pin. And it also has a timer to keep track of a movement. In case of the timer running out and it's time to shut down the display, we will execute this file, this command file. If it's the other way around, it's time to turn on the display. We have seen movement, basically. Then we will execute this file. And then at the end, if you're not too familiar with the concept of threading, what's happening down here is that I'm reinitializing my timer for the motion sensor. This means that the timer will wait for 0.5 seconds and then it will execute the function peer again. And then I start the threading task. This will automatically reinitialize itself every 0.5 second. And then it will go through this again, read IO pin, check it if it's time to do something, turn off or turn on the display, and then execute the command files. And if we go to the command files, I have them here as well. These can vary depending on your setup, your display, and so on. And it can be a bit tricky to find out the exact correct commands here. In my case, I use these commands, and I have been testing different setups many times here, but this is what I found the most useful ones. So this is the commands for turning off the display, and then you have for turning it back on. So these two command files is used for turning off and turning on the display when there's motion, and when motion stops, it's turned off. So let's just try to execute this part and see what happens, and then you will probably understand a bit more. This is one of the advantages of using Visual Studio Code and the remote extension. We can actually debug it from here. This debugger is much better than the built-in or the ones that you get, the one that you get with your Raspberry Pi. So I will execute the code, and you will see the debugging down here, and you can follow everything that goes on. Now it's actually running. So let's see if we bring up a browser. So remember, it was port 8081, and it was the root of the server, so I don't need anything else here. And there we have the clock. Very, very simple. So not much of a Magic Mirror yet, but it's a framework that at least works. Let's go back and have a look at my HTML file. As you probably know by now, I like to do this a lot manual and from scratch, meaning that I'm not using any applications to create my HTML code. I'm creating it from scratch, and then the reason is mostly because I think it's fun. It's fun, and I want to learn. I want to understand what I'm doing, understand the different tags. I want to have control of it as well. First, let's stop the debugger here so we don't have that running. And having a look at the code here, you can see that I have removed basically everything else that I have on my Magic Mirror. But if we start from the top, we have the header tag here. And coming into this, we have the title. Nothing strange. I've also set the refresh rate to 10 seconds here, so the page will actually reload every 10 seconds. And then we have the style. You can use CSS style sheets or whatever you feel more comfortable with. In my case, I've just added the style information here. A few settings for the body, and then a few settings for the default values for font sizes and for tables that I will be using a lot. Very simple HTML, but still it's useful and it works. Further down you can see that I have created a class for time. And these are the settings that will apply to the class time that you see down here. So here in the body, setting up the class time, and it gets its default values from this part here. So I'm positioning the time data exactly where I want it. Sometimes I do it pixel by pixel, sometimes I do it with percentage of the screen and so on. So it scales reasonably good. Not perfect, but reasonably good. But most of all, I want it exact on my display. So it's exactly where I need it to be on my Magic Mirror display. I can still bring it up from any browser and have a look at it as I did just now. And then coming down to the body, the class object, setting the defaults or the values for showing this. And then we have my data structure. So this is the JSON information that I sent or created previously, and you probably recognize it. Data is the name of the array that I sent. And since I'm reading the index 0 of the array, and I'm reading the value time. And if we go back to the Python code, you will see it here. So here I'm creating the array, and I'm adding the time value, a variable, and the time string. And here I'm sending back data to be called data on the HTML page. So I hope I explained it so it's understandable, but this is the framework I'm using, and this is the framework that I will be building on. It will become a lot more advanced, but basics concepts are actually here. I didn't comment on this one. This is at exit. And what it does is that when the application is closed, it makes sure by calling the interrupt function, makes sure to close down my threads. So it's canceling the threads. And as I add more threads here, I will be adding them here too. So it's cancelled properly before it shuts down. And the last line you probably figured out, this is where we actually start a web server. So here we have the IP address of the host. We enable threading. That's important if we want to do those calls to have things running in the background. We have the port. And then you have a debug flag that you can set to true or false if you want to. this last line will need to be lost because it will actually lock up the system, so it will stay here. So all the interrupts and threads needs to be started before we come to this last line.